The father of modern medicine, Hippocrates, once said, "Let medicine be thy food, and food be thy medicine." In 2025, nearly 1 million people will die from heart disease alone. Millions more will die from cancer and diabetes. Millions are diagnosed every year with high blood pressure, Alzheimer's, and obesity. What is going on? How can it be that with all the advancements in medicine, we keep getting sicker and sicker? Have we been lied to? What lays at the root of all of this? Dr. Robert Lufkin is a physician and medical school professor. With decades of experience, he is also the author of over 200 scientific peer-reviewed papers. He is the author of 14 books, including a New York Times bestseller, Lies I Taught in Medical School. He has also been featured on countless news and media outlets. Today, we are going to pull back the curtain. It's time to reassess. It's nice to meet you, Dr. Robert Lufkin. Thank you for being here.
Hey, Matthew. It's a pleasure. I'm really looking forward to our conversation.
Great. Well, so I just finished your book that you wrote called Lies I Taught in Medical School. And maybe you've been asked this before, but did you intentionally choose such a provocative title?
Yeah, I mean, it is, admittedly, it is clickbait. It kind of gets people's attention, Obviously, we want to get the message out, and, having a title like that gets more people to look twice at it. Although it really speaks to one of the fundamental principles of education and science itself, in that it's constantly changing and it's constantly evolving. What we thought was true before may not be true now. And I always quote one of the greatest physicians of all time, named Sir William Osler. Over 100 years ago, he made one of the greatest quotes about education and science when he was addressing a group of graduating medical students on the day that they were becoming doctors, and they just finished their medical school. And he said, famously, "Gentlemen," and at the time, most of them were male. He said, "Gentlemen, we have a confession to make. 50% of what we've just taught you is wrong. It's a lie. And furthermore, we don't know which half it is."
Oh, you love that. Yeah. You're just like, okay. I mean, I do think that is consistent with most education, not just medicine, because, when I think back to the things I was taught in school and the world I was prepared for, man, I'm living in a completely different world than what, I graduated high school back in 2011, and the world that mentally I was ready for and envisioned. It's like we are adapting to something completely different than what was presented to us.
Yeah, our understanding of reality changes when the tools that we have access to change. I mean, for thousands of years, diabetes, the disease, was diagnosed by sweetness in the urine, by how you might think of it. Yes, they would taste the urine, and it would taste sweet, and it was called diabetes mellitus. It means sugar urine disease, basically. And then over 100 years ago, people figured out glucose and how to test for glucose actually in the blood. And they realized that it wasn't just sugar in the urine, but it was also sugar or blood glucose. And then our understanding of diabetes changed. And then a few years later, insulin was discovered, the hormone that drives diabetes. And then our understanding of diabetes changed into type 1 and type 2 diabetes, which are really very different. They have similar sweet urine. They have similar high levels of blood sugar or glucose, but their insulin response is very, very different. And so as we understand more, if we have more and more tools to understand reality, we refine our understanding of, the diseases we face and everything that happens to us in life.
Absolutely. And I can't wait to talk about diabetes, because that's a subject that I'm particularly passionate about, given that my mom has struggled with diabetes and wrestled with it for the last 15 years. But I wanted to ask you first is what made you want to become a doctor?
Great question. The environment I was raised in, my dad was an engineer, so he was like kind of like science and looking at stuff that fascinated me. We build stuff. But my mom was a dietitian, which is a nutrition scientist basically, and she worked in hospitals. So from a very young age, I had the knowledge that, or the insight that somehow what we ate mattered to our health. It was connected somehow through nutrition. And interestingly, the reason she became a dietitian, I think, is because both her brother and her sister had type 1 diabetes, and they were raised in growing up, watching what they ate, because that was how you managed diabetes at that time. But probably that influence made me curious about health and wellness, and I just, one thing led to another, and I like medical science.
Yeah. And so you've written a number of other books, and I was looking at those, and they deal heavily with MRI, X-ray. So were you in the radiology sphere?
Yeah, my training is as medical imaging, so radiology, CT, MR, ultrasound, that kind of thing. And the other books I've written are actually textbooks. They're very technical books that nobody reads. That are very detailed in a very narrow area of things. So this current book is the first book that I've written for kind of a general audience, and it's been a new experience.
Yeah, I mean, I loved the book. I love that it was, a lay audience can understand it. And as a history aficionado, I like that you incorporated like a lot of the historical narratives behind our understanding of a lot of the diseases, some of the lies, and our current understanding. And so, was that intentional to include the history?
Yeah, I mean, like you, I love history, and I think history adds a richness of meaning to all the things we study. So it's fun to talk about fatty liver disease going back to the Egyptians, or just how things evolved historically, culturally. It's fascinating.
Yeah, that is. The part in your book about the one of the delicacies, is it geese, fatty liver in geese?
And the French call it foie gras. Yeah.
And they intentionally give them junk food, right, to fatten up their livers.
Yeah. They give them high carbohydrates, which is what most junk food is, and it causes their liver to turn fatty. And then that's a delicacy. The people eat it. They take the liver out of the animals and then spread it on toast or use it different ways. And it's been around for a couple thousand years. The Romans famously made it, and the Egyptians before them even. But today it's interesting that there were fatty liver disease in humans, but it was caused primarily from drinking alcohol. And it was called alcoholic fatty liver disease because the alcohol is detoxified in the liver. The liver is sort of among other things, a detoxification organ. And when we drink alcohol, it doesn't provide any energy anywhere in our body except in the liver. And the liver processes it and detoxifies it through a pathway that creates fat production in the liver that leads to fatty liver disease. Well, in the 1980s, a new type of liver disease arose, and it was interesting. It just like exploded on the scene, and all the doctors thought it was due to alcohol. So they would tell the patients, "Oh, you've got fatty liver disease. You need to stop drinking." And some of the patients would say, "Doctor, I've never had a drop of alcohol in my life," and they go, "Sure, but just stop it, whatever you're doing." And finally, children began getting it, and they realized that these children weren't drinking alcohol and something else was driving it. And fast forward today, 30 years, 40 years later, this new type of fatty liver disease that had never appeared before 1980 is now the number one cause of liver failure and liver transplants in the U.S. And they call it non-alcoholic fatty liver disease because it's not caused by alcohol. But there's a lot of evidence that we present in the book that this is driven by fructose, which is a sugar that's found in a lot of junk foods and high fructose corn syrup. And this fructose is, unlike glucose, which is a sugar that's used throughout our body for metabolism and energy, fructose is like alcohol. It's only processed by the liver, the detoxification thing. And interestingly, it has the same or very, very similar detoxification pathways, which mean the fructose leads to fat accumulation in the liver and fatty liver disease. And back to your original question, the Egyptians, the Romans, when they wanted to create foie gras in the geese, they would feed them. They wouldn't feed them protein because that really didn't work. They wouldn't feed them fat because that really wouldn't work. But the other macronutrient that did work was carbohydrates. So they fed them all different kinds of carbohydrates. And to this day, if you want to create fatty liver in an animal, just feed them carbohydrates or, a lot of junk food and you'll do it.
Or alcohol, maybe. Give them some alcohol.
Or alcohol, too. Yeah, alcohol will do it also.
You mentioned fructose, and as a kid, they teach you fructose comes from fruit, and it's kind of easy to remember that way. So kind of explain this, like, is eating an apple bad for you now, or like what's going on with that?
No, eating an apple is, hey, it keeps the doctor away, right? And we can look historically about fruit, and everyone says, hey, fruit's got to be healthy. We've been eating it for hundreds of thousands of years, as human beings. So now you're going to tell me this is unhealthy? Well, problem is a couple things. The fruit that occurred naturally in nature in most situations was in the fall before the winter came. And fruit contains fructose because fructose is designed to tell our bodies to store fat, to become insulin resistant, to put on weight. And that's what fructose does. By eating fruit, animals bulk up. The bears fatten up because they're going to go hibernate for 4 months, or animals are going to be in the winter when there's not much food. So it's a natural signaling or mechanism that happened once a year to prepare us for winter. The problem is today, fruit is available around the clock, around the year, and we're constantly preparing for a winter that never comes. We're constantly eating fruit, gaining weight to today. Sadly, in the United States, most people are fat or either obese or overweight. And similarly, many of the other chronic diseases we'll talk about are exploding that way. But the fruit now is not really meant to be consumed year round. The other problem with fruit today, modern fruit, compared to the fruit that our ancestors ate, is that, I don't know if you've ever seen pictures of an ancestral apple. It's about this big, it's a little tiny thing. It looks like a crab apple or a cranberry or something. And it's not really that sweet. We've, for better or worse, through, genetic engineering and selection and all, we've created, apples that are giant like this. They're juicy and they're full of sugar too. So the fruit we eat today has a higher sugar content, and it's not really designed to be eaten year round. So fructose in small amounts is healthy. And in fact, our body can handle small amounts normally without sending it to the liver. But it's a relatively small amount. And once we get above that, then it goes to the liver and it signals our body to start putting on weight, develop insulin resistance, and get ready for the winter.
Yeah. I have seen, even if you look at just like, apples that from apple trees that are maybe decades old, or something like that, like, or haven't been tampered with, they are much smaller. I have a friend who we went apple picking at his house, and I'm like, man, these apples are tiny. They're good, they taste a little different, but they're not like some of these other ones that I'm like literally like as bigger than my fist.
Yeah, and you're in apple country up there in Washington State, so yes.
Yeah. So that's fructose, and another thing that you talk about a lot is cholesterol, and this myth that cholesterol is the primary reason behind heart disease. And, I have friends who, and even relatives who are, in their mid 30s, and, it's like a ticking clock. It's like their doctor eventually is going to tell them, oh, you got to start watching that cholesterol. And pretty soon they're talking about maybe prescribing a statin. And so can you color in some of that history and why cholesterol, it might not be as damaging as they make it out to be?
Yeah, in the first half of the 20th century, people were eating a lot of saturated fat, a lot of cholesterol in their diet. It was just what they ate. But they were also doing something else. They were beginning to smoke a lot of cigarettes, and people started dying of heart disease. And famously, one of our presidents, Ike Eisenhower, had a heart attack that was covered very widely. And they realized, why are, relatively young people dropping dead of this heart disease? What's causing it? And some researchers, among them Ansel Keys and others, developed an idea that it was due to fat in the diet. And there's some earlier research very early in the 20th century where they fed rabbits high cholesterol food, and they developed plaques in their coronary arteries, which is the lesion that appears in the heart arteries. So cholesterol in the diet in these animals caused plaques to occur. The problem is that research is flawed because rabbits don't normally eat cholesterol. So when you feed it to animals that normally eat cholesterol, like humans or dogs or other type of animals, it doesn't really work that way. But some of the science was wrong. And then it caused Ansel Keys to look at saturated fat consumption around the world in different countries. And he sort of cherry-picked a group of countries that showed a correlation with fat intake and heart disease. He unfortunately omitted a lot of countries that didn't show that correlation. So it was based on bad data, but it started something that's been with us for the last 70 years. And that is the notion that high fat, saturated fat, cholesterol in the diet causes heart disease. And my mom, the dietitian, we grew up not eating butter because butter has saturated fat. And also is expensive, but so we ate margarines, which were supposedly healthy, but actually they're not healthy at all. They contain trans fats and pro-inflammatory seed oils, but we would switch from high fat to lower fat substitutes. And today that's the recommended diet. Avoid saturated fats and then some drugs came along. There's a drug called statins that actually lower the serum cholesterol, and now these are prescribed widely. Some doctors even say it should be in the drinking water, which is the problem with cholesterol and fat as a model for heart disease is that most people who have a heart attack have a normal blood cholesterol, so it's not that's strong an association. There's a small association with blood cholesterol and heart attack, but it's relatively small compared to other risk factors or so-called hazard ratios. Things like smoking is much worse than your blood cholesterol, or your metabolic profile. Your triglycerides, high triglycerides and low HDLs are more protective against heart disease than low LDL cholesterol. So it has a small effect. The problem is statins. You might say, well, heart disease is the number one killer, right? You, me, most of our audience. This is statistically what we'll likely die of, even today. So even if statins lower LDL cholesterol and give me a 1% advantage, hey, I'll take it, right? It's the number one killer. Why wouldn't you take it? Well, the problem with statins is they overestimate the benefits and they underestimate the risks. So there are a lot of harmful things on brain function with statins and diabetes and other things as well. So it's it's a complicated pathway, but it's really shaped public health policy, nutrition advice, the food pyramid, the American Heart Association, all these things for the last 60 years. Really, is the idea that fat somehow causes heart disease, which I believe, and the evidence is very strong in the book. We talk about how you're more likely to get a heart attack from eating donuts and sugar and carbohydrates than you are from eating fat or butter. And the evidence is pretty strong for that. But that message isn't getting out there to a lot of people.
I remember taking a class. It was I originally had thought I wanted to go into like exercise science. And I remember taking a class where the teacher was talking about heart attacks and heart disease and things like that. And he was saying that the sugar molecule, the way it's shaped and when it is traveling through arteries and it glides against the arterial wall, it can cause inflammation and little damage. And so it's the cholesterol that's going to try and repair. And it's an overaccumulation of the cholesterol, but it's sugar that it's causing it to happen in the first place. So why is it that we're not trying to just say eliminate the reason for why cholesterol is trying to patch up the inflammation in the first place?
Yeah, that's the great point, because cholesterol is in the lesions that cause heart disease. If you cut open the plaque, whether it's in rabbits or humans or any animal model, the plaques or the narrowing of the blood vessels contain cholesterol in them and fatty deposits. So the idea is, well, if fatty deposits are narrowing the vessels, then I don't want to eat fatty food. But as your teacher points out, this cholesterol is just a repair mechanism. It's not primary. It's not the driver. It's not the cause. It's the result of the lesion. And to give you evidence of that, people who have very low fat in their diets, but they smoke cigarettes, guess what? They get cholesterol plaques in their blood vessels too, even though their blood cholesterol is very, very low. And, similarly, other types of things, now we're finding out that ultra athletes with very high levels of exercise now get calcifications, which are a marker of damage in cholesterol in the blood vessels of the coronary arteries too. So there are a number of things that can drive it, but cholesterol is involved, but it doesn't appear to be causal. So lowering blood cholesterol doesn't have a big effect on heart disease. It's not what we need to worry about. It's things like sugar, which through glycation damages all proteins at high levels. That's what the hemoglobin A1C is that we use for diabetes, that blood test. It measures damage to red blood cells from high sugar levels. And this it's not just red blood cells, it's blood vessels and everything else that get damaged by just spikes in sugar from high carbohydrates.
Yeah, I mean, if people know that, you'd think that there would just be like, well, let's just attack it at the root cause. But there's, you talk about like this establishmentarianism in the medical field, and there being a lot of financial incentives to sell drugs. And so when you became a doctor, was there like this awareness of pharmaceutical companies trying to convince you that these drugs are good, or was it like a gradual sort of development?
I mean, I went to medical school a long time ago, but even then it was, they were drug companies would come around and give us pens and give us gifts and lunches, and there were all sorts of things going on that way. And those were the obvious influences. I mean, my lab, we used to do a lot of research with drug companies and device makers, and from the federal government, from NIH. Our lab got millions of dollars in grants. But it was interesting. Some of the drugs that we would evaluate, the drug companies would give us a grant to test the drug, to do an animal study or human study, and we would do it. But the contract with the drug company would say, before you publish it, we want to see the article and we have the right to refuse to allow it to be published. And what they would do is they would just this was designed to protect them from negative publicity. So if you do a drug trial and it fails, well, they don't want that evidence out there. So there was even that influence back then. But I think, it's just gotten worse and worse and worse because there's more and more and more money involved. The amount of money made from statins, that cholesterol drug, is more than the combined budgets of the NFL, the football league, the baseball league, and the NBA, the basketball leagues. And interestingly, the idea that these pharmaceutical companies can advertise directly to patients for their drugs, and we've all seen the ads on CNN and other things. It wasn't always that way. In fact, in the rest of the world, it's not that way. In fact, there are only 2 countries in the world that allow this to happen because of the harm it does, because it flows a lot of money into media, and there's corrupting influence, and New Zealand and the United States are the only countries in the world that allow drug companies to directly advertise their drugs. And politics aside, the new administration coming into the White House, the RFK Jr., the Health and Human Services Secretary, had one of his pledges is one of the things he's going to do is stop that, prevent that from happening anymore, eliminate pharmaceutical ads directly to patients. And it's, again, politics aside, it's interesting that, this hasn't happened before. There have been plenty of Republican and Democrat administrations, and nobody's bothered to do this. So, but it's a big corrupting influence. My mom, like I said, was the dietitian. You go to her conventions, and they were sponsored by Coca-Cola and McDonald's and junk food companies. And they paid for truly the education of dietitians. Well, it gets worse. When you go to doctors' conferences, they're paid for by drug companies, and drug companies truly influence and define education of physicians today.
Wow. That's incredible that, some of those sponsors are some of these brands that are just the worst. You mentioned RFK, and we don't have to go so far into politics, but do you think someone like him as the new Secretary of Health and Human Services is a good thing as a doctor?
Yeah, I mean, it's funny. This has become a political thing to say that. I mean, I have to say, I love my Republican friends. I love my Democratic friends, and I wish they just get along more, but I don't think this is a political issue. What do we call it? Make America Healthy Again. How is that political? It's sure the Republicans are kind of hijacking it as their brand, but it really shouldn't be. For the first time in my memory, we're having at a national level a political discussion where people are mentioning things like chronic disease, seed oils, pharmaceutical ads, inflammation, insulin resistance. These things have never appeared at a national level in any sort of political discourse, and they should be, because it's a health crisis we're facing like nothing before. It makes COVID-19 look like nothing.
Yeah, we are sicker than ever, and it just makes you wonder. You're just a layperson. Say, okay, our technology is improving, our understanding of the human body is supposedly more than it was 1,000 years ago, and our treatments we're investing so much in treatment, but why is it that the rates are getting worse? The rates of diabetes, the rates of cancer. It's we are obviously, as a society, engaged in a behavior practice that is contributing to make it worse. And so where is that coming from? Because if the rates should be coming down if the treatments are improving or if they're more effective, but the rates are going up.
Well, I'll give you my 2 cents. I'm a product of Western allopathic medicine. I'm still, last time I checked, I still have my job there. So I'm a product of the system, and I have to say, I'm still my book is critical of Western medicine, but I have to say I'm still a fan of it. In other words, Western medicine, today if I get hit by a car, I'm going to want a blood transfusion. I'm going to want my spleen removed. I'm going to want my bone set. And these things are what Western medicine excels at, acute things. And in the 20th century, even those of us who remember the 20th century, Western medicine transformed the lives of people all over the world. The pills, the surgeries, the technologies that were developed were truly magical, largely through public health measures and infectious disease, but they really, truly made the world a better place and increased the life expectancy of everyone. The problem is, in the 21st century, we're facing a tsunami of what are called chronic diseases. Now, these diseases were present in the 20th century, like we talked about, fatty liver disease and all, but they weren't at the numbers we are today. Today, these diseases, and the diseases go all the way from obesity, diabetes, hypertension, heart attack, stroke, cancer, Alzheimer's disease, and mental illness, just to call a group out like that. And these numbers we're facing unprecedented numbers. In other words, we talked about most people in America are overweight or obese. Most people have high blood pressure or they're being treated for hypertension. Almost half of people have diabetes or prediabetes. They're on the road to it. And it goes on and on and on. And, anybody who says, well, it's just your genes, just make sure you pick your parents right. Well, the fact that these are literally exploding to where most people have at least one chronic disease, our genes haven't changed in the last 30 years. Something else is going on. And that's really the thing. And then the question is, well, if the treatments are getting better, do we just need to spend more money? And that's questions that's often asked. And the U.S. already spends more money than any other country on healthcare. But our results aren't better than any other country. And the problem is, I don't believe it's about spending more money, because if you spend more money on the wrong things, you're not going to fix the disease. And right now we're spending money on the wrong things, like, lowering the cost of insulin, making it more available to people. Well, if insulin doesn't cure type 2 diabetes, and it doesn't, then you overlook the fact that lifestyle will cure type 2 diabetes. And most people can reverse their type 2 diabetes and get off medicines with lifestyle. But if you just make insulin cheaper and cheaper, you're just going to have more and more type 2 diabetics who then will progress to, amputation, blindness, kidney failure, and all the other complications that diabetes has. But if they treat it with diet, they don't get those complications because they stop the disease.
Yeah. On that same topic of diabetes, I mentioned earlier ago that my mom has diabetes, and, I think it's a good time to kind of bring attention to this. I think she was misdiagnosed as type 2, but she's also not type 1. And so maybe we can talk about this, and it's that there's a type of diabetes, some people call it type 1.5 or type 3C, which can come from an injury or damage to the pancreas, and it damages insulin production. Or you have type 1.5, which you develop it later in life. It gets misdiagnosed as type 2, but it could be an autoimmune thing that you develop after you turn 30, and it has some characteristics of type 1. What is the treatment for something like that?
Yeah. Well, for your audience, type 1 diabetes is generally, it's a failure of the pancreas to produce enough insulin. And these people require insulin to be alive, to prevent high blood sugar and other effects. Type 2 diabetes, which is the vast majority of people today, over 90% have type 2 diabetes, is due to insulin resistance. In other words, where the body keeps producing insulin, but the pancreas produces insulin, but the body becomes resistant to it. So it takes higher and higher levels of insulin to control the blood sugar. And eventually, type 2 diabetics, many of them will, quote, burn out the pancreas. In other words, they'll get higher and higher levels of insulin, and eventually their pancreas will fail, and they'll essentially convert to like a type 1 diabetic because the pancreas just is unable to produce insulin anymore. So there's these two main groups, but in between there's a lot of different spectrum is in there. The great thing about type 2 diabetes is it's been shown by controlled prospective studies from Virta and other places that this can be reversed and controlled with diet alone, even reversing medications. Type 1 diabetes, we're now finding that diet also has a dramatic impact on the insulin requirements. So you could lower the amount of insulin, but you still need insulin for type 1. But there's just a fascinating paper that just came out using partial epigenetic reprogramming, which you may have talked about in the context of longevity. Shinji Yamanaka won the Nobel Prize for these so-called Yamanaka factors, which are chemicals or drugs that will take adult cells or adult stem cells or adult regular cells or aged cells and wind them back to a more youthful appearance. And Dave Sinclair, famously at Harvard, is doing this to reverse age-related blindness in mice, and now they're doing it in humans with these Yamanaka factors and similar type agents. But regarding type 1 diabetes, there's a breakthrough paper that just came out where they took the patient's own pancreatic cells using Yamanaka type factors, partial epigenetic reprogramming. They wound them back to a more youthful epigenetic state, and they took the patient's own cells and put them underneath the abdominal wall, just injected them there. And because they're the patient's own cells, they don't need immunosuppression like you would with a heart transplant or a pancreas transplant or anything like that, which has all sorts of problems in itself. So it's the patient's own cells. You just inject them back in. And this is very, very preliminary work, but it's so exciting. It's transformative. The patient that they did this with, the type 1 diabetic who was insulin dependent, they followed them for a year, and for a year they haven't required any insulin. And now they're doing more and more studies on this partial epigenetic reprogramming, not only for type 1 diabetes or retinal blindness. You think of any age-related disease where the cells get old and you want to rewind them back to a more youthful state. This is powerful, game-changing technology that we're gonna see a lot more of in the very, very near future.
Yeah, I mean, that would be really cool, especially for people who have organs that are not functioning properly, and you kind of rewind the clock. That's incredible. I kind of want to just go into like a quick fire round here. You talk about cancer in the book being a metabolic disease. There's a lot of theories out there, whether it's gene related to your DNA or caused by mutating genes. And I thought this was really cool. One of the historical aspects, I haven't heard about this, but the Dr. Otto Warburg, who you talk about in the book, kind of famously discovered that cancer cells metabolize energy like from glucose. And it just seems like that's sort of ignored in today.
Yeah, it's a great point, great question. And speaking of that, another paper just came out a week ago about cancer and this particular question. I'll save that for the end. Let me set the framework. Otto Warburg was a German scientist. Famously, he worked in the early days of Germany and then later under Adolf Hitler. And it was particularly interesting because although he was one of Hitler's top scientists, he was also Jewish and homosexual. And the only reason that he was able to stay alive, given Adolf Hitler, was that Hitler feared cancer more than he feared homosexuals or Jewish people. But he's a quirky kind of wonderful guy. There's a book called Ravenous out there by Sam Apple that tells his story. But just to give you an example, he won the Nobel Prize, and when he won the Nobel Prize, his response was, "It's about time." He was like, very full of himself. But he did some amazing work about metabolism and mitochondria and phosphorylation. But one of his discoveries was that cancer cells have defective mitochondria and they can't metabolize. Their metabolism of glucose is impaired, so they require large amounts of glucose. And we see that today. One of the imaging tests for cancer is a PET scan that looks at glucose utilization, and cancer always has high glucose utilization. So he discovered that, and that was the so-called metabolic basis for cancer. And why isn't everyone doing that now? Why aren't we aware of it? Well, a couple of things happened. Well, first of all, Hitler lost the war, thank God, and this guy wasn't very popular because he was a German Nazi. He wasn't a Nazi, but he was, in the German party. But something even more significant happened. Just as he was moving to the United States and talking about his work, there was a discovery that in 1953, two gentlemen described the double helix. Francis Crick and James Watson described the helical structure of DNA, and that captivated the world's attention. Suddenly, the world of medicine was viewed through the lens of molecular biology. In other words, DNA. Everything was a DNA mutation. We were going to understand DNA, and we would understand all diseases and everything else. Great thing about DNA, there's 600,000 base pairs, but it's not infinite. With metabolism, it's much more complicated and much more almost infinite. So, long story short, beginning in 1950s, DNA took over as the model for all disease, basically, and including cancer. And it's been the focus of cancer for the last 40 years. And there's no question that that DNA damage is present in cancer. No question. It's also no question that metabolic abnormalities are present in cancer, mitochondrial damage as well. The key question is what causes which one. In other words, if DNA damage is primary and the metabolic change follows the DNA damage, then you want to fix the DNA damage, and vice versa. If the metabolic abnormality is primary and the DNA damage is secondary, you want to do that. So what happened? Fast forward to the early 2000s, there was the Human Genome Project. Finally, we mapped the human genome. Huge fanfare all over the world. This is a glorious victory for humanity and understanding medicine. So they began developing some gene therapy type drugs for cancer. And there were some amazing breakthroughs, Gleevec and, Philadelphia chromosome, that story. There's some really home runs with DNA therapy. And then someone said, well, let's just get all the tumors together and map their DNA and find the map of tumor mutations in DNA, just like we did for the Human Genome Project, only it'll be the Tumor Genome Project. We'll map all the cancer mutations, then we'll just develop drugs for each one, and we'll cure cancer. That happened in 2010. Basically, they completed the Tumor Genome Project. Nobody's heard of it. Why not? Well, because it was a terrible failure. What they realized was that there's very little consistency in genetic mutations. In other words, some tumors had no mutations. Other tumors had different mutations in each metastasis. And so it fell through. But anyway, long answer. I'll wrap up with that paper that just came out, breakthrough paper, looking at malignant brain tumors, glioblastoma multiforme, they're called. And it's a small paper, but what they did was they tried metabolic therapy in addition to standard therapy. And glioblastoma multiforme is a terrible, rapidly progressive disease. There's been little progress made in treatment since Teddy Kennedy got it a few years ago. Most people die within 18 months, no matter what you do. Well, these people took two groups with this terrible disease, and they put half of them on a ketogenic diet. A ketogenic diet is a metabolically healthy diet that basically does what Otto Warburg says we should do to tumors. It cuts off the glucose for them. But anyway, their small study, admittedly small study, showed that of patients who did not do on the metabolically, the ketogenic diet, just the regular diet, 6% of the glioblastoma patients lived to 3 years. And the ones who went on a ketogenic diet, almost 70% lived to 3 years. So it's a huge, huge difference. It's a small population, single digits of people. It's preliminary, but it's so powerful. It's so exciting. I think it's going to get a lot more attention now. Metabolic therapy for cancer.
The first time I heard about ketogenic diet was in like 2015, 2016, and it was kind of like everywhere. And then it kind of died down a little bit. And now it's there's this huge resurgence. You talk about it in your book a lot. But now I think it's more, there's a lot of carnivore keto people out there. And I think man, this one's sort of withstanding the test of time a little bit. I definitely, cutting off glucose seems like an obvious therapy. But I want to ask you, and sorry that this is kind of a morbid question, but I think people would be interested, if you developed cancer today, what's the first thing you would do?
Well, first thing I would say is I'm enough of a product of Western medicine that I would look very closely at the recommended treatment. So I don't think we're at a place where ketogenic therapy replaces mainstream treatments. So I would look at the mainstream treatments, but I would add on ketogenic therapy. And ketogenic therapy is all about, it's basically the lifestyle that benefits obesity, diabetes. All the chronic diseases benefit from a low junk food diet, which is a low carb diet, which is a ketogenic diet. So it's all the same message, and it reduces your risk, I believe, for all those chronic diseases, including cancer there. So I would follow the mainstream recommendations from the best people I could find, but I would dive into longevity. I would dive into lifestyle as well. But I think an important message for people in the book is, as a doctor, I used to think that diseases started when the doctor diagnosed it. You come into the office and, you've got diabetes, whereas 2 weeks ago you didn't, or, you forgot your keys, you have Alzheimer's disease. I don't mean to make light of any of these diseases, but I want to illustrate the principle. Now I realize that literally all the chronic diseases that we're talking about today don't begin the moment the doctor diagnoses them. They begin years to decades before that. Well, what does that mean? That means if I wait for the doctor to tell me I have one of these diseases, and let's face it, we're all going to get one of these diseases, at least, probably many of them. That's what's going to kill us statistically. But we want to push it back as long as we can. And so if I wait until the doctor diagnoses one of these diseases, I've missed a tremendous opportunity for prevention. And that's possible through lifestyle. Because people say, well, why should I change my lifestyle now? I'm healthy. I don't have any diseases. Well, no, actually you do. They haven't been diagnosed yet. They're crumbing along. Trust me. After age about 25, they all start, in various different rates. Not everybody gets all the diseases, but everybody gets at least one, right? Nobody gets out alive.
Yeah. Well, as we wrap up, and thank you for that. I think that's really helpful, just to, stretch out your vision of the future, start living now as though you're trying to prevent these diseases from coming. And, it could be all in vain. You could get hit by a truck tomorrow, right? We're never guaranteed tomorrow. And however, for the things that are within your control, it makes sense to start pursuing. And I think people are waking up to that. I think right now there's sort of like a movement boiling and growing. You see it with RFK, you see it with people, like Jordan Peterson and a lot of these guys who are, talking about carnivore diet and the ketogenic diet. And if you spend any time on social media, I mean, you're being exposed to this, that there's a growing culture of trying to pursue longevity, health and wellness and those sort of things. I think it's all great. For one last thing, I'd be remiss if I didn't mention Bitcoin on this show, because that is one of the primary topics of discussion. I think it goes hand in hand with somebody on their health journey, right? Like when you're on a health journey, you are constantly learning about how to improve your health, and you come over a rim of insights, and there's a whole nother horizon to be explored. And I think there's a lot of correlations that with Bitcoin, because Bitcoin sort of has that same sort of journey, and a lot of Bitcoiners are really interested in health and stuff like that. And so is Bitcoin something that you've ever explored or?
Sure. I love cryptocurrency. I think it's a fascinating concept. It's always, it's always on the edge. I mean, just to tell you how long ago it was, I used to mine Bitcoin when you could still mine them with a CPU.
Oh, wow.
And then eventually you could only do it on a GPU. And then eventually after that, you had to do it on a dedicated processor. But it's fascinating, it's fascinating technology. I'm always curious to see it evolving. The idea of a, distributed blockchain technology it holds so much potential for, other than a financial currency, for so many different things. And so hopefully we'll see a lot more of it in healthcare going in the future.
Yeah, that'd be cool to see some of the blockchain technologies and how they could affect healthcare. Well, if you ever come up to Spokane, maybe we'll have you at one of the Bitcoin meetups that I host.
All right.
So your book is called Lies I Taught in Medical School. I hear there's a chapter people can read for free online at your website.
Sure. Yeah. It's my website is robertlufkinmd.com, and you can download a free chapter, both PDF and audio there, the first chapter. See if you like it.
Awesome. And do you have a podcast yourself?
I do. Yeah, I have one that comes out every week, and we talk about health and longevity and different topics and different interesting people. That you can find it on the website there. We have about usually an audience of about 400,000.
Wow, that's amazing. Well, I am going to be giving away 10 of your books. So if there's anybody listening and you want a copy, you just have to leave a comment and subscribe or repost, whatever. That'll make you enter, and I'll just pick some people at random. But I'm excited to share a lot of the contents that and insights that I gained from your book. And so I thank you for writing it, and I am deeply thankful for your time today, Dr. Robert Lufkin.
Oh, thanks so much, Matthew. This has been fun. I really enjoyed our conversation.
Yeah, you have a great day.